IBM's quantum composer enabled us to experiment with different quantum states and made us particularly interested in superposition and entanglement. First, we made two qubits go into the quantum state by adding a H-gate to our circuit. This superposition allows the creation of entangled states, where the state of one particle can be determined only by looking at its sibling state. However, quantum computers that we use today are not perfect. While superposition allows two pieces to be reliant on each other, random noise disrupts the perfect symmetry. What you're looking at is a representation of two entangled qubits. We want you to experience the core idea of quantum in real life in an approachable and elegant manner. We 3D printed two Petri dishes, each with a mirror attached to its base and filled with water. The Petri dishes are placed on top of two speakers that oscillate according to the frequency and amplitude of the music. There are two projectors. Each projector is adjacent to a Petri dish and screens a different P5JS sketch onto the mirrors. The two projections are then reflected onto the ceiling or wall, where they meet and form the complete visualization of the two entangled qubits.
With our gate configuration, the qubits exist mainly in two states, as 00s and 11s, or as noise, the 01s and 10s. State 00 is represented by our first medium, which is the projection, and state 11 is represented by our second medium, which is sound, using the quantum music playground. By overlapping the two mediums, we show the in-between states of the qubits, the uncertainty of their states, and clarify that one cannot know their states until one measures them. With IBM's quantum composer, we created a quantum circuit and ran our data. In the array that was generated, 48.5% of the qubits existed in state 00. 45% of them existed in state 11. The rest of the qubits were noise, meaning that they existed in the either state of 10 or 01. Each projection represents one qubit in state 0. If both qubits are in state 0, the projection is a symmetrical pattern because the qubits are entangled. Every now and then, the pattern on either projection glitches. This disruption of the perfect symmetry is caused by noise when the qubits are in state 01 or 10.
Next, we will move on to sound. Each speaker represents one qubit in state 1. The quantum music composer enabled us to create a base audio with the state 11. The base audio is then played through the two speakers, which create sound waves of different amplitudes and frequencies. This sound energy is then converted to kinetic energy in the water, creating interesting waveforms in the Petri dishes. Due to the water movement caused by the oscillation of the speakers, the P5 projection in each Petri dish is then warped according to the 11 state of the quantum circuit. As a result, the final projection on the ceiling is influenced by the 00, 11, and noise states, accurately illustrating superposition and entanglement of qubits present in our quantum system.